Problem F915. Determine the surface area and the volume of the solid formed by revolving the shaded area 360 degrees about the z-axis. So for this, we are going to use the theorems of Pappus and Guldenius in chapter 9 or section 9.3 of your textbook. To find the surface area, the formula is A equals theta times r bar times L. Theta is the angle that the figure is rotated, in this case 360 degrees, but it needs to be in radians, so theta is 2 pi. R bar is the average location, or the average distance from the z-axis of all of the lines that make up this, or that get rotated to make the surface. And L is the total length of all the lines that make up the surface. Now I've been using the qualifier that make up the surface because this line right here, the line that's along the z-axis, is not counted in either of those. So to find length, we find the lengths of each of these now 1, 2, 3, 4 line segments and add them together. And to find r bar, the centroid of those, we find the r times L, add them together. So for the 4 pieces, first, this top piece. It has a length of 15 inches because it goes from the axis to 0 to 15 inches. And its average location is halfway of the 15 inches. So the average location is 7.5 inches. For this line right here, the vertical side, it has a length of 18 inches as given right there. And it spins its entire length at the same distance from the axis. So it is entirely at 15 inches, so the average is 15 inches. Now the diagonal side can be a bit tricky because the length of the diagonal side is not 20 inches, it's not 30 inches. This is a diagonal, which means we need to find the length of this hypotenuse right here. Now it goes 20 inches in the z direction, and then 15 inches in the r direction, because it doesn't start here at the origin, it starts out here 15 inches out. So 20 inches is one side, 15 inches is the other side. We can recognize this is a 3, 4, 5 triangle, which means the length of this diagonal is 25 inches. As for its average location, the average location is the location at the center point, at the halfway point, which is 15 inches, or the halfway between 15 inches and 30 inches, which is 22.5 inches. And the bottom side, we can do the same thing we did to the top side. It has a length of 30 inches, and its halfway point, or its average point, is right there in the middle, so the average is 15 inches. Next, we find this weighted location, the sum of L times R. So this first term is the first length times the first R, 15 inches times 7.5 inches is 112.5 square inches. This one is 18 inches times 15 inches is 270 square inches, and so on. To give a total weighted length of 1,395 square inches. To find the total length, add up these 4 lengths, and you get 88 inches. We can find the average location in the r direction by taking the weighted length divided by the total length, 1,395 square inches divided by 88 inches, to get 15.85 inches. So just a little bit beyond this point right here. Then we go and use our formula to find the area. So angle of rotation is 2 pi. The total, or the location of the centroid is 15.85 inches from the axis of rotation. The total length is 88 inches, giving a total surface area of 8,765 square inches. Second part, what is the volume of this shape? We have a similar formula for volume. Volume is equal to theta r bar A. Theta is again the angle of rotation, which again must be in radians, so again 2 pi. R bar we can find using our weighted averages again. So this time I'm going to break this shape up into two pieces. I'm going to say that this piece right here is a rectangle, and then this piece right here is a triangle. Now this is not the only way you can divide this shape. You can say rectangle, rectangle, triangle. You could even, if you wanted to be difficult, say triangle and another triangle. But I'm going to go with one rectangle and one triangle. So for the rectangle, the area of a rectangle is base times height, 15 inches times 38 inches. And for the triangle, it's 1/2 base times height. The base is 15 inches. The height is 20 inches for a total area of 150 square inches. For the average location for the centroid of these two shapes, for the rectangle, it's the halfway point, so half of 15 inches or 7.5 inches. For the triangle, remember the centroid of a triangle is 1/3 of the length from the right angle. So this length is 15 inches, 1/3 of that is 5 inches. Plus this side, this right angle is 15 inches separate. So 15 inches plus 5 inches or 20 inches. We then find the weighted area is 570 square inches times 7.5 inches, 4275 cubic inches. 150 square inches times 20 inches, 3,000 cubic inches. So the total weighted average or weighted area is 7,275 cubic inches. We can find the total area by adding these two areas and get 720 square inches. So we can find the centroid of that grade figure as the weighted area divided by the total area, or 10.104 inches. And we can finally calculate the volume using this formula. Theta is 2 pi, r bar is 10.104 inches, and area is 720 square inches, or 45,710 cubic inches. Now, you might notice I've made this a little more difficult for myself than I had to. In both cases, to find r bar, I took the weighted average and divided by length in this first case, or weighted average and divided by area in the second case. But then for both formulas, the next thing I did was multiply by length and multiply by area. So in reality, this step wasn't actually necessary, and this step wasn't necessary. All I just needed to do was take this value, that's this right here, multiply it by my angle of rotation, and that would have sufficed.